Have you ever looked up at the night sky and felt a sense of wonder? Well, right now, something is happening out there that's turning that wonder into a chilling mystery. An interstellar visitor, a comet named 3I Atlas, is defying everything we thought we knew about these cosmic travelers. It's not just another rock hurtling through space. It's a puzzle that's getting more terrifying the closer it gets to Mars. On September 14th, something incredible happened. Comet 3I Atlas, which was supposed to be a faint, predictable object, suddenly exploded in brightness. It wasn't a gentle flicker. It was a full-blown eruption, creating a ghostly green shroud 500,000 kilometers wide. For perspective, that's wider than the planet Jupiter. And the chemistry? It's completely backwards. The comet is spewing out 8 times more carbon dioxide than water, a ratio that has astronomers completely baffled. This sudden surge sent shockwaves through the astronomy community. Online forums and official channels lit up with a mix of confusion, excitement, and even a little alarm. As this comet accelerates towards a close flyby of Mars, it's even developed a strange anti-tail that points directly at the sun. But here's where it gets truly strange. Just as the mystery deepens, many of our most powerful observatories have gone silent. Critical data seems to be vanishing. What is really happening out there, and why the secrecy? The first signs that something was wrong appeared on the night of September 7th. All around the world, from Tokyo to Arizona, amateur astronomers and data analysts, the spreadsheet jockeys of the cosmos, watched their live charts go haywire. Comet 3I Atlas was predicted to brighten by just a tiny fraction each week. Instead, it leaped by 1.6 magnitudes in less than 3 days. That might not sound like much, but in astronomical terms, it's like a firecracker suddenly going off like a stick of dynamite. The first raw measurements came from dedicated amateurs like Robert McNaught and Kei Yoshimoto. Their data, time-stamped and uploaded for the world to see, showed the comet jumping from a faint magnitude 10.4 to a much brighter 8.8 almost overnight. A surge like that isn't just a small detail. It's a siren blaring in the quiet of space. It meant the comet was suddenly reflecting 4 times more light than any of our models predicted. Imagine a dimmer switch in a dark room being instantly cranked to full brightness. That's what happened to 3I Atlas. Within hours, astronomy forums like the Comet OBS mailing list and Cloudy Nights were flooded with new data points. Every new observation confirmed the first. The comet's brightness wasn't climbing slowly. It was shooting straight up a vertical wall on the graphs. Immediately, debates began. Some seasoned observers argued it was a natural outburst, a pocket of frozen carbon dioxide gas bursting through the comet's crust. Others were more cautious, whispering about potential errors in the instruments or misinterpretations of the data. Could the expanding Coma be tricking the telescopes? But the numbers kept coming, each new entry confirming the last, each one a direct challenge to the established rules of cometary behavior. For a few electrifying hours, the story belonged entirely to these night owl amateurs. Their raw data, posted in real time, became the beating heart of a global skywatch. No one knew what the next observation would bring, but everyone understood the stakes were high. When the light curve of a celestial object breaks this dramatically, it means the cosmos is trying to tell us something we don't yet have the words to describe. Let's talk about the sheer scale of this event, because the numbers are staggering. As of mid-September, the solid core of 3I Atlas is estimated to be no wider than 3 kilometers. That's a tiny speck smaller than most city parks. Yet this tiny object is venting carbon dioxide at a mind-boggling rate of 129 kilograms per second. To put that in perspective, that's like a small truckload of dry ice vaporizing into space every single minute, all from that one tiny nucleus. Hubble's sharpest images confirm the core's small size. Yet the Coma, the hazy cloud of gas and dust surrounding it, has ballooned to over 700,000 kilometers in diameter. That is nearly twice the distance from the Earth to the Moon. All of this material, this vast ghostly cloud, is emanating from a single frozen speck. But it's not just the size of the outburst that's so strange. The chemistry itself is what truly defies explanation. Most comets in our solar system are like cosmic snowballs, primarily made of water ice. They wake up gradually as they get closer to the sun, and the heat causes the water ice to sublimate, turning directly into gas. But with 3I Atlas, water is barely a supporting actor. The James Webb Space Telescope pointed its powerful instruments at the comet, and what it found was shocking. The spectrum revealed a carbon dioxide-to-water ratio of 8:1. That's not just unusual. It's completely off the charts. Normally, comets in our solar system show far more water than carbon dioxide, often by a factor of 10 or more. They are water-rich. But 3I Atlas flips that entire hierarchy on its head. Carbon dioxide is the dominant gas, with water trailing far behind, and other compounds like carbon monoxide are barely present at all. The JWST team, led by spectroscopist Dr. Alicia Franzi, flagged this anomaly in their very first data releases. Her group's models had predicted a slow, steady increase in activity as the comet neared the Sun. But the reality was a runaway greenhouse effect in deep space, with carbon dioxide pouring out at a distance from the Sun where water ice should still be frozen solid. This isn't just an interstellar comet. It's a cosmic outlier. It's behaving in a way we've never seen before, challenging our fundamental understanding of how these objects form and evolve. The fact that it's so rich in carbon dioxide suggests it may have formed in a very different, much colder environment than our own solar system's comets. But even that doesn't fully explain the violence of its recent outburst. What force could trigger such a massive and sudden release of gas from such a small body? Is it an internal process we've never witnessed, or was it triggered by something external? The questions are piling up, and the answers remain elusive, hidden in the ghostly green glow of this mysterious visitor. The plot thickens when we consider the comet's origin. It's an interstellar object, meaning it doesn't belong to our solar system. It has traveled for millions, perhaps billions of years through the vast, empty space between the stars. And now it has arrived here, bringing with it secrets from a distant, unknown stellar neighborhood. But this isn't the first interstellar visitor we've seen. Remember Oumuamua and Borisov? Oumuamua was a bizarre cigar-shaped object that tumbled end over end, and Borisov looked and acted much like one of our own comets. 3I Atlas is different from both. It's a hybrid, a chimera, showing characteristics that don't neatly fit into any category we have. And what about its future? Its trajectory is taking it on a close pass by Mars. This is an incredible scientific opportunity. As it gets closer, the Sun's radiation will intensify, and we can expect even more dramatic changes. Will it break apart completely? Will it have another, even bigger outburst? This is a live experiment unfolding in our cosmic backyard. But this is also where the story takes a darker turn. As interest in 3I Atlas peaks, access to crucial data seems to be narrowing. Several major ground and space-based observatories, which would normally be leading the charge on an event like this, have been unusually quiet. Official data releases have slowed to a trickle. Is it a coincidence? Or is something being deliberately withheld from the public? This information vacuum is being filled by speculation and theory. Some suggest the unusual composition and behavior could point to something beyond a natural origin. Could this be more than just a comet? The high carbon dioxide content, the sudden and powerful outgassing, these are features that, in a different context, might look like a propulsion system. Of course, that's a wild leap, but in the absence of clear data and open communication from official sources, it's a thought that's hard to ignore. We're witnessing an unprecedented cosmic event, a messenger from another star system that is breaking all the rules. And just as it gets most interesting, the curtains are being drawn. The silence from the big players only amplifies the importance of the amateur community, the citizen scientists who continue to track 3I Atlas every night. Their data, shared openly and freely, is our clearest window into what's happening. They are piecing together the puzzle, one observation at a time. What we are seeing is a cosmic mystery of the highest order. Is 3I Atlas a natural wonder that will rewrite our textbooks? Or is it something more, a piece of alien technology, masquerading as a comet? The answers might challenge our very definition of what's natural, what's technological, and what secrets are being kept in the dark. As 3I Atlas continues its journey toward Mars, one thing is certain: the universe has our attention. Every telescope pointed its way is looking for clues for the next piece of this incredible story. We'll be following this closely, so make sure you stay tuned for updates. What do you think is happening with this mysterious comet? Let me know your theories in the comments below. Something strange is happening in our solar system. A visitor from deep space, a comet designated 3I Atlas, is defying everything we thought we knew about these icy wanderers. It's not just another rock hurtling through the void. It's a puzzle, a mystery that's forcing astronomers to rewrite their textbooks. As one scientist put it, we're seeing a comet whose engine is running on a different fuel entirely, and the more we look, the stranger it gets. The story begins with a peculiar glow. On September 16th, something caught the eye of astronomers monitoring the skies. A spike of light at a specific wavelength, 518 nanometers, right in the heart of the green part of the spectrum. It was sharper and appeared much earlier than any model predicted. The first automated flags came from the Gemini South telescope, where the imaging pipeline, managed that week by a sharp astronomer named Catalina Hernandez, started stamping every frame of Atlas with an asterisk. Her private note to her colleagues was telling. "The green envelope," she wrote, "cut through the pre-dawn sky like a chemical torch." This was completely unexpected, given how far the comet still was from the sun. This wasn't some faint, subtle hue. Visual observers, amateur and professional alike, across 3 different continents, reported seeing the same eerie, almost electric green glow. For anyone who understands comet chemistry, this specific shade of green means one thing: diatomic carbon, or C2. Normally, comets save this green display for when they get much closer to the sun. The intense solar radiation is needed to break apart organic molecules on the comet's surface, releasing the carbon and making it glow through a process called fluorescence. It's a signature move, but it has a specific timing. Comets are supposed to follow a script, a gradual ramp-up of this green light as they cross certain temperature thresholds on their journey inward. Atlas, however, tore up the script. Spectrographs from observatories in Chile, Poland, and Hawaii all confirmed the same thing: an early, dramatic crescendo of green light. It was punching through the background noise of space with a confidence that left no room for doubt. The intensity of this emission line was staggering, rivaling some of the brightest comets ever recorded, even though Atlas was still navigating the cold outer reaches of our solar system. Naturally, the scientific community is cautious. Hernandez herself urged her team to double and triple-check the data, circulating raw and processed images side by side to rule out any digital artifacts or tricks of the camera lens. "We're not chasing ghosts," she cautioned in an email, "but this is a regime where ghosts can look real." But as the data poured in from around the world, a consensus began to form. The green was real. It was intrinsic to the comet. This interstellar visitor wasn't just big. It was wearing a spectral badge that set it apart from everything that had come before. And the implications of this early green glow go far beyond just a pretty color. They point to a fundamental difference in the comet's composition and behavior. The technical explanation is simple on paper. Carbon-rich material is being liberated from the comet's nucleus and energized by sunlight. But the why is the billion-dollar question. Why is it happening so early and so violently? This isn't just a minor deviation from the norm. It's a complete departure from the established rules. Some began to speculate about an ultra-dense, concentrated ejection of carbon from the comet's core, something never witnessed before. The comet's vast, swollen atmosphere, its coma, now had a chemical signature that screamed, "I'm different." But the weirdness doesn't stop with its chemistry. High-resolution images, captured by powerful ground-based telescope arrays and orbiting observatories like Hubble, revealed another anomaly. The Coma, the huge cloud of gas and dust surrounding the comet's nucleus, wasn't the uniform, fuzzy ball we're used to seeing. Instead, it was laced with intricate, thread-like structures, dusty plasma filaments stretching for tens of thousands of kilometers. These filaments weren't static. They were seen twisting and shifting over timescales of just a few hours. This hints at something far more dynamic and complex than a simple, steady release of gas. It suggests non-equilibrium processes are at play, maybe even organized outflows. It's as if the comet's tiny nucleus is riddled with powerful jets or vents, actively channeling gas and dust into space in discrete, forceful streams, sculpting the coma from within. Think of it less like a block of dry ice sublimating in the sun and more like a geyser field erupting. This brings us to the most mind-bending part of the Atlas puzzle: the scale mismatch. The nucleus, the solid core of the comet, is estimated to be incredibly small, perhaps only a few kilometers across the size of a small city. Yet this tiny rock is wrapped in an atmosphere, a coma that is swollen to planetary scale, dwarfing even planets like Jupiter. The sheer volume of gas and dust being pumped out is staggering, outpacing our best models by orders of magnitude. Physics gives us a baseline. To produce the amount of water vapor alone that has been measured, a minimum of 8% of the comet's surface would need to be actively releasing gas. But the data on carbon dioxide production suggests even more aggressive venting is happening. The numbers just don't add up. How can such a small object produce such a colossal and complex output? One leading theory tries to bridge this gap. Grain-lifting models propose that powerful eruptions of carbon dioxide from beneath the surface are not just releasing gas, but are also lofting vast quantities of fine submicron-sized ice grains high into the coma. These tiny ice particles then travel far from the core before they sublimate, turning directly from solid to gas, feeding the envelope's vast reach from the inside out. This is a mechanism that is rarely, if ever, seen on this scale. It's an incredibly efficient way to build a massive coma, but it requires a very specific set of conditions and a tremendous amount of energy. It's hard to overstate how strange all of this is. We have a city-sized rock generating an atmosphere that dwarfs planets. We have gas output that our models can explain. We have a chemical signature, that early green glow that reads like a recipe from a different solar system. And we have a complex, filamentary structure in its coma that hints at powerful, organized jets on a tiny nucleus. For now, the numbers stand as their own warning and a thrilling invitation. A warning that our understanding of comets might be incomplete, and an invitation to explore a new frontier of cometary physics. Something about 3I Atlas is fundamentally different. It's rewriting the rules, 1 kilogram of unexpected carbon dioxide, 1 eerie green photon at a time. This isn't just another comet. It's a messenger from the interstellar void, and it's carrying a message that we are only just beginning to decipher. The ongoing observations of Atlas promise to be some of the most exciting astronomical events in recent memory, potentially changing our place in the cosmic neighborhood. Have you ever looked up at the night sky and seen something that just doesn't make sense? Something that breaks all the rules we thought we knew? Get ready, because we're about to journey to the edge of our understanding to meet a cosmic traveler that's doing just that. This isn't just another comet. This is 3I Atlas, and it's putting on a show that has scientists completely baffled. Imagine this. A comet still far from the sun suddenly begins to glow with an intense emerald green light. Normally, this green hue, caused by a molecule called diatomic carbon, only appears when a comet gets close to the sun's heat. But Atlas started glowing way too early and way too brightly. It was like a firefly lighting up in the dead of winter. It was hypnotic. For a few nights, the sky gifted us a spectacle that defied all expectations. Scientists rushed to their telescopes, trying to make sense of it. Was it made of some exotic chemistry from a distant, unknown star system? Was it packed with unusual frozen gases? Every theory just added to the mystery. The numbers told a story of incredible energy, of molecules being torn apart and rebuilt in the cold emptiness of space. But behind all the data, one question echoed in every observatory. What kind of object wears an emerald halo before it's supposed to? And what else is it hiding in its light? Just when we thought things couldn't get any stranger, something impossible happened. On September 9th, a sharp spike of light shot out from the comet. But it wasn't pointing away from the sun like a normal tail. It was pointing asterisk towards asterisk it. This is what astronomers call an anti-tail, and it's an incredibly rare optical illusion. It's like a cosmic magic trick. Here's how it works. Comet Atlas is on a bizarre backwards orbit, almost completely tilted relative to our solar system. For a few brief nights, Earth's position lined up perfectly with the comet's path. This alignment created a trick of perspective, making the trail of dust the comet had left behind months ago look like it was shooting forward, straight at the sun. It was a fleeting alignment, a perfect cosmic coincidence, and it turned the comet's dust into a luminous spear captured in stunning images from Poland to Chile. But this illusion was just the beginning of the puzzle. A team of scientists in Warsaw, led by Dr. Marek Nowak, decided to look at the light from this anti-tail in a special way. They measured its polarization, which tells us about the texture and structure of the dust particles. What they found was jaw-dropping. Most comets have a negative polarization value of around -1 or 2%. This is a sign of fluffy, porous dust grains, but Atlas? It clocked in at a staggering -2.7%. In the world of comet science, that's a 5-alarm fire. This number is deeper and stronger than any comet we've ever seen, suggesting that this isn't just random dust. It's something more. The particles seem to be organized, maybe aligned into tiny filaments or sheets, creating a structure that polarizes light far beyond the norm. So what could create such a highly ordered structure out of simple dust? The comet's chemistry might hold a clue. We know Atlas is rich in carbon dioxide gas. As this frozen gas warms up, it can erupt in violent jets, blasting fine dust grains out into space. If these jets are channeled through cracks and vents on the comet's surface, they could sweep the dust into coherent, organized streams. Each one of these streams would then act like a tiny polarizing filter, combining to produce the extreme signal the Warsaw team detected. The pieces are starting to fit together. The team noticed that the anti-tail's brightness and its extreme polarization peaked at the same time, suggesting they share a common origin. It all happened when the sun was grazing the dust almost head-on, an angle that maximizes this strange effect. An extreme polarization reading like this is a hallmark of dust built in the cold, dark void of interstellar space. But the sheer extremity of this measurement, -2.7%, pushes Atlas into uncharted territory. No comet from our solar system has ever shown this combination of a deep polarization and a distinct, organized dust spike. For now, that sunward-pointing spike, the anti-tail, stands as a silent enigma. It is visible proof that the cloud around 3I Atlas isn't just a random puff of cosmic dust. It's something more ordered, more deliberate. It's a structure that is both breathtakingly beautiful and deeply unsettling. A cosmic geometry that defies any easy explanation. And the story is far from over. There's a date circled in red on every space mission planner's calendar, October 3rd, 2025. On that day, Comet 3I Atlas will make its closest approach to Earth, passing us at a distance of about 71 million kilometers. This is our golden opportunity. Missions are being planned right now to get a closer look. Imagine sending a probe to fly through that mysterious green coma, to sample that strangely organized dust. What will we find? Will we discover a new type of cometary physics, driven by its unique chemical makeup and violent outgassing? Or could the data point to something else entirely? The highly ordered structure of the dust has led some to whisper about a more radical idea. What if this order isn't natural? Could it be a sign of technology? A solar sail, a beacon, or something we can't even imagine? It's a wild thought, but when the data pushes us into territory this strange, we have to keep an open mind. Is 3I Atlas a natural wonder that will rewrite our textbooks on comets? Or is it our first real encounter with something engineered? The answer is out there waiting for us. October 2025 isn't just a date on a calendar. It's a rendezvous with mystery. And you can be sure we'll be watching, waiting to see what secrets this emerald traveler will finally reveal. Mark your calendars for October 3rd, 2024. This isn't just another day. It's a day that could rewrite the history of planetary science. An interstellar visitor, a comet named 3I Atlas, is about to make a close pass by Mars, skimming by at a distance of just 28 million kilometers. Now, I know what you're thinking. We hear about comets all the time. But this is different. This is an object from beyond our solar system, getting closer to a planet than any interstellar object we've ever been able to observe. This is a rare, fleeting, and absolutely unmissable opportunity. High above the red planet, a fleet of orbiters, NASA's Mars Reconnaissance Orbiter and the European Space Agency SXOMARS Trace Gas Orbiter and Mars Express are facing a high-stakes dilemma. The science teams are practically begging for every possible image, every scrap of data. But the operations teams are, quite rightly, cautious. Retargeting a billion-dollar spacecraft on such short notice is incredibly risky. The comet's path is being updated almost daily, leaving zero room for error. Think of it like a cosmic game of chess but with much higher stakes. Each orbiter has its own rules, its own limitations. The angle of the solar panels, the amount of data it can send back to Earth, crucial safety margins for the instruments, everything has to be perfectly calculated. The window to even attempt an observation isn't measured in days or weeks. It's measured in hours. It's a nail-biting, down-to-the-wire decision. And the pressure is on because the sky is absolutely buzzing with activity right now. It's not just Atlas. In late September, another comet, 414P Pan-STARRS, is zipping through its closest approach to the Sun. Comet Swan is grabbing headlines with its own close flyby of Earth. Comet Lemon is on its way for a November encounter with the Sun. Plus, a whole wave of asteroids is weaving through the inner solar system. It's like cosmic rush hour. This creates a kind of observational triage for mission directors. Do they stick to their carefully planned schedules, studying the familiar objects they already know? Or do they risk it all, diverting precious resources to this mysterious interstellar traveler that's already breaking all the rules? It's a huge gamble. Miss this, and you miss a once-in-a-generation event. But a single mistake could compromise an entire mission. Behind the scenes, schedules that are normally locked in months in advance are being torn up and rewritten overnight. The stress is immense. Every single adjustment, every change in the plan, carries a risk. You could miss critical data, or worse, violate a safety protocol and damage an instrument. But the scientific prize is just too tempting to ignore. No Mars orbiter has ever captured an interstellar comet this close to a planet. The data we could get would be revolutionary. It could tell us about the structure of its dust, how it releases gas as it warms up, and the fundamental physics of these visitors from deep space. It's a chance to answer questions we've barely even known how to ask. As October 3rd gets closer, the feeling is undeniable. This is a one-shot deal. The sky might be crowded, but for a few critical hours, every eye, both human and robotic, will be locked on this single, enigmatic object hurtling through our cosmic neighborhood. To truly understand the excitement and the anxiety surrounding 3I Atlas, we need to look at its predecessors. These were the only other two interstellar objects we've ever confirmed, and they were our first yardsticks for the unknown. And they couldn't have been more different from each other. First, back in 2017, came 1I Aumua. The name means scout in Hawaiian, and it arrived like a complete riddle wrapped in an enigma. It was this dark, elongated, cigar-shaped object tumbling through space. It had no coma, that fuzzy halo of gas and dust we expect from a comet. It had no tail. Its brightness flickered as it rotated. But here's the truly bizarre part. Its path through the solar system deviated ever so slightly from the one dictated by gravity alone. It was being pushed by something, but with no visible outgassing, no rocket-like effect, we still can't explain what that something was. Oumuamua was subtle, persistent, and to this day, profoundly mysterious. Then, just 2 years later, in 2019, 2I Borisov arrived. And it was the polar opposite. Borisov was the textbook interstellar comet we had always hoped to find. It had a prominent coma and a beautiful tail. Its activity, driven by the sublimation of water and carbon monoxide, behaved exactly as our models predicted. It was a perfect, well-behaved visitor from another star system. The numbers made sense. The physics held up. Borisov was reassuring. It showed us that comets from other stars could look and act just like our own. So when 3I Atlas was discovered, scientists had these two very different precedents. Would it be a silent mystery like Oumuamua? Or a classic predictable comet like Borisov? Naturally, they prepared for both. They loaded their data pipelines with routines trained on Borisov's steady, predictable brightening, but they also kept in mind Oumuamua's stubborn silence. The working assumption was that Atlas would be something in between, maybe a bit more like Borisov. They expected a light curve that would rise as it neared the sun, a coma that would expand with the heat, and outgassing that would trace a familiar, predictable arc. But Atlas had other plans. It didn't follow the script. As it drew closer to the sun, its behavior became more and more erratic. The data pouring in from telescopes around the world started to paint a picture of an object that was not just unique but actively defying our expectations. The neat, orderly models based on Borisov simply weren't working. The first hint that something was unusual was its coma. It wasn't just a mix of gas and dust. It was dominated by carbon dioxide. This was a major clue. On comets from our own solar system, water is usually the main driver of activity. CO₂-rich composition suggests that Atlas formed in a very different, likely much colder, environment. It was the first solid piece of evidence that this visitor was truly alien. Then its brightness started to do strange things. Instead of a smooth, steady increase, its light curve began to stutter and flare. There were sudden, sharp increases in brightness, followed by periods of relative calm. This wasn't the slow, graceful awakening of a typical comet. This looked more like a series of violent, explosive outbursts. Each flare-up suggested that chunks of the comet's surface were breaking off, exposing fresh ice to the intense heat of the sun, causing it to vaporize explosively. And then the biggest shock came in the spring of 2024. Observers noticed that the comet wasn't just a single point of light anymore. It had fragmented. The nucleus, the solid core of the comet, had broken into at least two and possibly more distinct pieces. This wasn't a gentle shedding of material. This was a catastrophic failure. 3I Atlas was disintegrating right before our eyes. This changed everything. The mission planners for the Mars orbiters were no longer tracking a single, solid object. They were now trying to aim their instruments at a complex, evolving cloud of debris. The target was now multiple fragments, each with its own trajectory, surrounded by an expanding shroud of gas and dust. It turned a difficult task into an absolute nightmare of astrodynamics. This fragmentation was both a crisis and an incredible opportunity. On one hand, the comet might completely fall apart before it even reaches Mars, leaving nothing to see. But on the other hand, this disintegration is a natural experiment of cosmic proportions. By studying how it breaks apart, we can learn about its internal structure, its tensile strength, and the materials holding it together. We're getting a look inside an interstellar object, a chance that scientists could only have dreamed of. So, as the fragments of 3I Atlas race toward their October 3rd rendezvous with Mars, the stakes are higher than ever. The object is rewriting the playbook on interstellar comets in real time. It wasn't the silent enigma of Oumuamua, nor the predictable classic of Borisov. It is something new, something chaotic, and something utterly spectacular. For the teams controlling our Mars orbiters, this is no longer just an observation. It's a rescue mission to capture the last moments of a dying visitor from another star. The data from those few hours could be the only legacy it leaves behind. What happens next won't just be another interesting discovery in a busy year. It will set the precedent for how we, as a species, respond when the universe throws us a curveball, when a new, chaotic, and exciting chapter of exploration is thrown wide open. For centuries, we've scanned the heavens, listening for a whisper, a signal, a sign that we are not alone. We've built colossal telescopes, launched probes into the void, and sent our own messages into the cosmic dark. Yet, the universe has remained stubbornly silent. But what if the first message wasn't a signal at all? What if it was a visitor, hiding in plain sight, disguised as something utterly mundane? Today we delve into the story of 3 Atlas, an interstellar traveler that started as a scientific curiosity and became a canvas for our greatest hopes and fears. A story that forces us to ask, is it just a weird rock, or is it something more? When 3 Atlas first swam into our view, astronomers felt a sense of cosmic déjà vu. Our telescopes were primed, ready to flag any strange behavior, any tiny nudge that wasn't caused by gravity alone. We'd seen it before with Oumuamua's mysterious drift, that slight, inexplicable acceleration that sparked so much debate. And we'd seen the opposite with Borisov, a classic interstellar comet that behaved exactly as the textbooks predicted. For the first few weeks, 3 Atlas seemed to be following Borisov's script. Its brightness increased gently, just as our models of comets predicted. Teams at JPL, the European Space Agency, and Harvard ran the numbers again and again. The verdict was clear: no non-gravitational push. The comet was sticking to its path, a perfect arc through our solar system, requiring no extra corrections. It was a foreigner, yes, but one that seemed to play by our rules. For a moment, it felt like a simple repeat, another dot on the chart. Then September came and everything changed. Suddenly, 3 Atlas flared. Its brightness didn't just rise. It skyrocketed. The hazy cloud around it, its coma, expanded at a runaway pace, growing larger and more brilliant by the hour. When our instruments analyzed the light, they found something astonishing. The coma wasn't dominated by water vapor, the hallmark of nearly every comet we've ever studied. Instead, it was overwhelmingly rich in carbon dioxide. Each new piece of data stretched our understanding of what a comet could be. Scientists at the Minor Planet Center scrambled, combing through every scrap of tracking data, searching for that telltale Oumuamua-like acceleration. They found nothing. The comet's path remained stubbornly, perfectly gravitational. The anomaly, it seemed, wasn't in its motion, but in its very nature. The physics, the chemistry, the structure, it was all wrong. The baseline of what we expected from a comet, once a source of comfort, now became the frame for a profound mystery. The evidence pointed not to a comet trying to escape, but to one whose internal engine was unlike anything we had ever witnessed. With no strange movements to explain, the focus shifted from its path to its composition. The real deviations, and perhaps the real answers, lay hidden in its chemistry and the dust it was shedding into space. And where data is thin, speculation thrives. In the echoing silence of the cosmos, the idea that 3 Atlas might be more than a simple comet began to take root. Was it a scout ship in disguise? A piece of alien technology? The first deliberate visitor from another star? These aren't just late-night radio show theories. They are born from specific, puzzling data points. The case for an artificial origin rests on 3 main pillars. First, that strange engine. The comet's coma, saturated with carbon dioxide instead of water, is the primary clue. To some, this suggests an engine running on an unfamiliar fuel. They argue that carbon dioxide isn't just a simple ice that sublimates in the sun. In the right configuration, it's a powerful propellant. The physics here isn't science fiction. We know direct solar heating can cause jets of CO₂ to erupt from a comet's surface. But what if a structure was deliberately built to harvest and expel this gas? It could potentially maneuver, or at the very least dramatically alter its brightness, just as we were observing. Could this be a controlled process, not a natural one? The second pillar is its light. A team in Warsaw measured the polarization of the light reflecting off the comet's dust. They found a value of -2.7%, the deepest, most extreme negative polarization ever recorded for any comet in recent memory. To some commentators and online sleuths, this was a smoking gun, a signature that could only be produced by organized, uniform dust particles or perhaps even artificial filaments designed to reflect light in a specific way. The academic world, however, pushed back. They pointed out that laboratory experiments with very fluffy, fractal-like grains of dust can produce similar effects, especially if those grains become electrically charged and aligned within a CO₂-rich coma. The science is complex and messy, but the speculation is seductively simple. Order where chaos should reign. A strange geometry in the light that seems to whisper of intelligent design. And the third, most controversial pillar, the data blackout. As September rolled on and the comet grew more fascinating, the flow of new public images and data seemed to slow to a trickle. This silence from major observatories became fuel for 1,000 theories. Was this gap a simple, boring result of the comet's position near the sun, making it hard to observe? Or was it something more? Evidence of managed information, a curtain being drawn just as the show was getting good? Influencers and online communities framed it as a deliberate pattern, a cover-up. Meanwhile, professional astronomers cited the same constraints that have plagued observations for decades. Safety margins to protect telescope optics from the sun, unavoidable delays in data processing, and the relentless, inconvenient geometry of our own solar system. Looming over this whole debate is the Fermi paradox. If the universe is teeming with intelligent life, where is everybody? One potential answer is that they're hiding. If you wanted to explore a star system without causing a panic, what better way than to camouflage your probe among the natural swarms of comets and asteroids? Why not slip into the statistical noise? A wolf in sheep's clothing. The engineered scenario is incredibly compelling. The carbon dioxide acts as both camouflage and propellant. The strange polarization becomes a coded signal. The data blackout becomes a deliberate pause to avoid detection. Yet each of these claims teeters on the very edge of plausibility, always one step ahead of what the evidence can definitively prove. For now, the hard data supports only what we can see. A comet that breaks the established rules of cometary science, but not the fundamental laws of physics. Hubble's images from July are still publicly accessible. The James Webb Space Telescope's spectral data from early August made its way through the processing pipeline without any unusual delay. The rest is a story we tell ourselves, a mirror reflecting our own deep-seated hunger for meaning, for connection, in the vast, silent darkness between the stars. Is 3 Atlas a messenger? Or is it simply a mirror showing us what we want to see? The truth, as always, is out there waiting for us to find it. Have you ever heard of Comet 3 Atlas? For a moment, it was poised to be the astronomical story of the year. This interstellar traveler was rewriting the rulebook on comets. But then, just as things got really fascinating, the most powerful eyes on Earth were forced to look away. What exactly happened during that blackout, and what does it tell us about our place in the cosmos? Let's take a closer look. It all started back in September 2025. The Minor Planet Center sent out an alert. Spectroscopy, which is a way of analyzing light to see what something is made of, revealed a colossal cloud of carbon dioxide gas. This cloud, or Coma, was over 700,000 kilometers wide. To put that in perspective, that's a fog bank the size of a small country, all spewing from a nucleus, the solid part of the comet, that was estimated to be less than 3 kilometers across. Imagine a tiny ice cube creating that much vapor. The sheer volume was completely off the charts. It shattered our existing models of how comets are supposed to work. But the oddities didn't stop there. When astronomers measured the light reflecting off the comet's dust, they looked at something called polarization. Modelers calculated that a sudden change in velocity of just 10 kilometers per second, which is a plausible event for a highly active comet like this, could have been enough to shift its path from a distant flyby of Mars to something much, much closer. Now, to be crystal clear, this was never a forecast of what would happen. It was a sensitivity analysis, a way to measure how a tiny, unobservable change could lead to a dramatically different outcome. It's a stark reminder of how finely balanced these cosmic encounters can be. Then, it swung around the sun, a period astronomers call conjunction, where it was completely obscured. All we could do was wait. That long wait finally ended in late November. As 3 Atlas emerged from the sun's glare, it once again became visible to our telescopes. Its closest approach to Earth was on December 19th at a very safe distance, I should add, but it was our first real chance to see what, if anything, had happened during the blackout. Astronomers were on high alert, looking for any signs of change. Had the nucleus fragmented? Was there a trail of debris left in its wake? Had its course been altered, even slightly? Behind the scenes, in internal memos and private discussions, the language used was cautious and scientific. They spoke of a window of risk, of searching for fragmentation signatures and carefully monitoring for micro-debris. Stakes were never about danger to Earth, but about knowledge. What we lost in that blind spot wasn't our safety, but a priceless, once-in-a-lifetime opportunity to witness a rare interstellar object in its most active and transformative phase. While the 3 pillars of mystery remain firmly in place, we still have a light curve that broke every model we have.